Assalamualaikum wabarakatuh. My name is Iqbal Muhammad Noor. My matrix number is 10VN21 at 1086. I'm from Demposi. I would like to talk about closed loop. Definition of closed loop is a closed loop control system is a mechanical or electronic device that automatically regulates the system to maintain a desired state or set point without human interaction. It uses a feedback system or sensor. Okay, these are how the electric iron for closed loop system is working. The basic working performed by an automatic electric iron is such that when the temperature of the sole plate attains a predefined value, then the heating action gets stopped automatically. And when the temperature falls below a certain specific value, then again heating starts inside it. This block diagram of electric iron. First, input go to the thermostat. When thermostat is the function in electric iron is to make sure that the iron doesn't get too hot. If it is left untended to for a period of time. So the function like a controller and heating element is a actuator and solid plate of iron process and go to the controller output and if the heat not get a point, the feedback go to the thermostat again and go to the actuator process and control output. This is advantage of electric iron systems. Advantage of electronic iron system is it did not allow your clothes to shrink. Second, it did not charge anything to contact people. Third, it had to adjust the cloth to look so perfect. Lastly, it is easy to handle compared to steam iron because steam irons are difficult to handle because of the hot and heavy steam. The electric iron is weak and is easy to operate. Next, disadvantage of electric iron system. It's cost to high electric bills because it uses current to operate the electric iron. Second, without electricity, it cannot ever run, and we can operate or we can use electric iron without current. So it is important to use current, to use electric iron. Future improvement in an electric iron control system that I think is use sensor to detect when steel surface touch the cloth for a long time to cut off electricity because to prevent the cloth from being damaged and burned. Second, able to adjust temperature according to thickness of the clothes. Examples, it using a thin fabric such as baju burung, the temperature should be low to prevent the fabric from being damaged.
Now I will talk about the example of the closed loop system with block diagrams. The example number one is home thermostat. In home thermostat, we have the input go to the controller and the controller go to the system. The system will give the output. But when the disturbance will apply in the system, the sensor will give the feedback and go back to the input. The second example is the temperature control system. In temperature control system, we have the valve that is controller, the steam flow that is actuator, and the tank that is the process, and go out to the output. The feedback for temperature control system that is the pressure thermometer. And example number three, we have the air conditioning system. For air conditioning system, we have the input and go to the signal, and we apply the electric power. go to AC, and AC will apply the output. The feedback for the air conditioning system is measured device. The example number 4 is the water level control. In water level control, we have the input and the controller, that is the level controller. The actuator is level control valve and process water storage tank. And for the output is water level in the tank. The feedback for the water level control is level transducer. The last example, we have the drying machine. In drying machine, we have the input go to the controller, and the heating element, that is the actuator, and the clothes, that is the process, and go to the output. The feedback for drying machine, that is the sensor.
Very good day, madam. My name is Kendrick, Joshant, KAVINTHIRA, KELVIN, and my matrix number is 01DEM21F1087. And I'm from the class DEM4C. So, in this case study presentation, I will be sharing and explaining about the open loop system. So, basically, what an open loop system is a system that is designed to help manage or regulate a process or a system. It uses outputs such as sensors or signals to measure the output of the system and then adjust the input to achieve the desired output. So basically, an open loop system is a system in which the output is not fed back to the input. It does not have any effect on the input. It responds to the input and produces output, and there is no feedback given to the system again once the output is created. So it's a type of control system where output is not measured and fed back to the input for correction. The input, on the other hand, is determined by the designer or the operator, or can say the programmer as well, based on the desired output. This means the system is not be able to make adjustments or corrections based on changes in the output. So it is not a standalone system. So basically, this is the block diagram of a basic open loop system. So it starts off with the process response, also known as the input, in which we'll go into our controller, which is our control system. Once the controller determines the input given, it outputs it as a process, and after the process is taken place, it will give us our output. As you can see, it is an open loop system. This is the basic concept of an open loop system. So there are many advantages and disadvantages of each and every system. So basically, these are the advantages and disadvantages of an open loop system. So firstly, look at the advantages. So basically, open loop systems are simple in design. They are inexpensive and very simple to operate as well. So this keeps costs down and also gives simplicity in operation for the user. On the other hand, there are a few disadvantages as well. So, in high accuracy or high precision applications, it is not applicable to use an open loop system. It is as it is not accurate in high precision tasks, and it does not produce output based on the conditions. So it gives output based on what is inputted in the first place, and it also is not consistent in outputs, whereby it may vary from time to time as the loop repeats itself again. So to sum up everything, open loop systems are a type of control system that relies solely on predetermined outputs without taking into account any changes that happens along the way from the output. While they are simple and inexpensive, it is not suitable that the processes require a high degree of accuracy. So they are not suitable for process that what require high accuracy and also consistency. So this is the basic concept of an open loop system. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh, and hi, my name is Muhammad Fahmi bin ZAINAL ABIDIN, matrix number 01BEM21F1073. Now I will talk about example of open loop system with the block diagram. The example number 1 is electric clothes dryer. In electric clothes dryer, we have the input and the controller, that is the timer. The output is the heating element and the process, that is clothes. The improvement to be made for the electric clothes dryer is first addition of moisture and temperature sensor. The number 2, addition of auto drying function when moisture or low temperature is detected. And number 3, airflow control. The second example is TV remote control. For TV remote control, we have input is remote control button. The controller is TV remote. The output is TV receiver, and the process is TV. Inputs to be made is introduce tactile feedback, and number 2, voice recognition and control. For the example number 3 is the home alarm system. In home alarm system, we have the input and the controller is the impact sensor, and the output is the control unit or receiver, and the process is the alarm siren. The improvement to be made is number 1, introduce PIR motion sensor. Number 2, introduce temperature sensor, and number 3, convert into a cloud-enabled IoT based system. The example number 4, we have the toaster. In the toaster, for the input is the power, the controller is the thermostat, and the output is the timer. The process is the brake holder or spring. The improvement to be made is number 1, automatic burn detection of brake. Number 2, cut off in case of over toasting of brake. And number 3, IoT cloud-based control. For the last example is the coffee maker. In coffee maker, have the input, that is the power, controller is the water supply, the output is the water savior, and the process is the filtration process. The improvement to be made is number 1, introduce water level sensor, and number 2, convert into a cloud-enabled IoT based system.